Question 10. Alright, and we're doing linear interpolation again, we're doing mean, we're doing standard deviation. Okay, very key topics inside this topic. Okay, part A. Use your calculator to find mean and standard deviation. Okay, hopefully we know how to do mean here. Just a slight difference here is we're using the midpoints. Okay, that is not the midpoint. We're using the midpoints of these ranges. Okay, so 12, 14 and 16. So what I'm going to do is 12 times 12 plus 14 times 14 plus 16 times 4. Okay, that divided by 12 plus 14 plus 4, which is 30, and we're getting 13.5. Okay, and I'm just going to write a little note down here that we've got our cumulative frequency is 30. Okay, it's our number of data points that we're working with. Alright, now standard deviation. Okay, so whenever you find standard deviation, first, we have our variance formula. Okay, leave out the square root until the end, but don't forget it. Okay, very important. So we got the sum of x squared over n take away x bar squared. Okay, so you've already got the mean, which is our x bar. If you haven't seen it written like that, you've already got your mean, so kind of keep that in answer. And then how do we find the sum of these x squares? Okay, well, temperature is all our data points. Okay, so our kind of, as you say, our x is here in this formula for variance is all our data points. Okay, so realistically, this is actually, we've got kind of 11, 11.1, 11.5, I don't know, 11.6. We've got all this data. Okay, but we've grouped it together and we said there's 12 points between 11 and 13. Okay, fine, know that. Alright, so we're taking our midpoint as 12. Okay, and we're saying all the points between 11 and 13, we're just saying they're 12 and there's 12 of them. Okay, and how does this translate? Well, then we need to do 12 squared. Okay, because this is our sum of all our x squares. Okay, well, we're doing 12 squared plus 12 squared plus 12 squared. Okay, so our sum just ends up being 12 squared times 12, 14 squared times 14, 16 squared times 4. Okay, because we're not doing like our 11 squared plus 11.1 squared plus 11.5 squared plus 11.6 squared. Okay, we're not doing that, we're just saying all of these are 12, so 12 squared, and then we've got 12 of them. Okay, so just kind of, it's important, even though we've been given this formula, to understand what's going on and to be able to use this with frequency or whatever data points we end up getting. Okay, so let's find our sum of our x squareds. So our sum of our x squareds is going to be, like I said, so we've got 12 squared times 12 plus 14 squared times 14 plus 16 squared times 4. Okay, so let me start solving some stuff into my formula. So our variance is going to equal, this is 45496 over 30, take away 404 over 30, all of that squared. Okay, so let's put that into this calculation here, into the calculator, and we get our variance is 1.848 square root that. I haven't rounded that. That's where you do the dot dots. When you haven't rounded it, you do dot dots. Okay, which is showing this is currently in my calculator to the examiner. I'm not going to write all those digits. I'm just going to give you that the standard deviation is going to be the square root of this, and now here's where I round it, and let's say this is 1.36 to 3 significant figures. Okay, perfect. So we've done that, we found the mean, found the standard deviation. Now we need to use linear interpolation to find an estimate for the 10% and 90% interpercentile range. Okay, a lot of words there. Let's decode what it wants. So this is like the standard example where we have lower quartile, upper quartile, interquartile range. Instead here, interpercentile range, well, we're working with this 90% and this 10%. Alright, so interpercentile, that's kind of what that means. Pretty self-explanatory. So, linear interpolation. What is linear interpolation? Well, linear interpolation, long kind of story short, is we've got these ranges, so we've got 11 to 13, and like I said beforehand, we don't know how this data is distributed between 11 and 13, or it could be all here, or it could be kind of spaced out. We're assuming that it is evenly spaced out. Okay, so if we have our 12 data points, they're all evenly kind of shared out in that number line. Okay, so 10% to 90%. So we need to find 10%. Okay, well, that's the third value. Okay, 10% is going to be the third value. Why is it the third value? Well, it's 10% of 30. Okay, so we're finding the third value, which is going to be in this 11 to 13 range. Okay, 11 to 13. Now, you might have learned a formula at school, might be a bit different to how I do it here, but I don't remember a formula. I kind of work it out through thinking about it. Okay, so we've got 12 data points from 11 to 13. Okay, so that means that we want to split this up into 12. That's why I do 1 over 12. Okay, and as we go across, we need to go from 11 to 13. So we need to go across 2. So each point is a sixth, right? Because we've got, if you do it over if you go across a sixth 12 times, then you're going to make up this 2, right? So that's how we figure out it's even. So I know that, okay, this is how much I'm going across. I'm going across a sixth, but how many times I need to go across? Well, I need to find the third data point. Okay, so I need to go across 3 times. So I times this by 3. Okay, and I've started at 11, so then my 10% kind of point is going to be 11 plus this, 12 times 3 times 2, okay, which hopefully you can see that's a half, so we've got 11.5. Okay, that's our 10%. Now we need to find 90%, okay, which is going to be 27, or 27th point, okay. So where's our 27th point going to be? Well, this is 26. Oh, you can't see that. This is 26 together. So cumulatively, it's going to be in this 15 to 17 range. So let's come down here. Let's write out our 15 to 17 again. Okay, and we want the first one, right? Because that will give us our 27th point, the first one. But what is the first jump? Okay, what is the first jump? Well, the first jump is going to be a quarter times 2, right? Because we're only jumping 4 times because there's only 4 data points here. Okay, so each jump is going to be a half. That kind of makes sense there. Okay, now I need the what point did I need? Did I say? I needed the 27th point, so I need to jump once. Okay, I need to jump once, so I'm just timesing this by 1. So we got 15 plus, well, a half times 1, so a half. So we got 15.5. So then our interpercentile range, okay, our interpercentile range is then going to be 4. Our interpercentile range is 4. Perfect. Estimate, this is an estimate. Amazing. Now we're doing another estimate. Estimate the number of days in September, fine, where the daily mean temperature in this place is more than 1 standard deviation greater than the mean. Okay, the number of days where the daily mean temperature, okay, we know what this is. We got that as 37, is more than 1 standard deviation greater than. Okay, lots of words. Let's write some stuff down. Okay, so we need to have our mean plus 1 standard deviation. What is a mean plus 1 standard deviation? Well, 13.5 plus 1.36. Okay, so 14.86. Okay, so now taking out all these words, they want the estimate for the number of days where it's just greater than 14.86. Okay, all those words now translates to 14.86. So number of days where the mean temperature is greater than 14.86. Okay, good. So if we're going back down to our kind of range, right? We're using an estimate here. We're what we're doing? We're kind of saying they're evenly distributed. Okay, 14.86 lies between 13 and 15. Okay, 13 and 15 needs to be broken up into 1/14. Okay, times 2. So we need to get over to a seventh. So every time you're adding, you're going across by a seventh. Okay, bear with me. So if we were to kind of work backwards, okay, we know that there's 26 points up to here. Okay, so 15 is our 26th point because we've got 26 bits of data here. Okay, now what is a seventh back from this? So we're going back a seventh. So we've got 15 take away a seventh, which is 14.857. Okay, 14.857. Alright, so we've got 14.857. 1. Okay, there's going to be some rounding here, so we need to be careful. Right, a mean plus 1 standard deviation. Okay, how exact were we with our working? 14.86. These were rounded. Aha. So this standard deviation is actually less. Okay, if you have this not rounded, sorry, this would be just to the left of it. Just to the left of it here. Okay, so it's inside here. So this is, sorry, our 14.86, and this is kind of one less, our 25th value here. Okay, so the question, sorry, was how many are greater than this? Well, you've got 5 greater than it, right? So then our answer here is we've got 5 greater, because we've got 30, 29, 28, 27, and 26. Okay, this rounding error is a bit strange here. You could also round them both to 86 and just say, just take it as these cancels, so we've only got our 26th, our 27th, our 28th, our 29th, and our 30th. I think that's better, actually. Okay, as you can see, I kind of reversed it a bit from knowing 5 is the final answer. So yeah, so these both round to 14.86. So these are not less, and yeah, hopefully that kind of makes sense. What's going on there. Thank you for listening.